micronutrients really should equally, once in the wrong layer, really should equally focus on vitamins and minerals. But in this particular tutorial, we're going to take the minerals route and focus almost all of our energy and concentration here. I'm going to talk you through 4 or 5 different minerals, and I'm going to touch on vitamins right at the end. I just want to talk a little bit about the specific role of those minerals in the body and how they influence performance, activity, and also health. So the first thing I'm going to talk to you about, guys, and I should really do this in sort of like a grey colour, I think. I'm going to talk to you about iron. There's my iron grey right there. And you guys probably already know that we can get iron into our diet through things like meat, especially lean meats, things like fish, and especially things like leafy veg, think spinach, for example. Okay, these are classic sources. And the reason that iron is particularly important to health and also to performance is that it is absolutely crucial to the production of HB, that being hemoglobin, that iron-rich protein which sits on red blood cells and does oxygen transportation as well as some CO2 transportation. And this process has a name. And by the way, this is really one of my problem spellings. I have to actually stop every time I spell this word. There's an I in there. This an I as well. Erythropoiesis. Erythropoiesis is the production of red blood cells, including, of course, hemoglobin, those biconcave erythrocytes in the bone marrow of particularly long bones. That's what we call erythropoiesis. That's why EPO, or erythropoietin, is typically a synthetic drug that will be used by sort of aerobic athletes. And why is it important? It's really important for O2 transportation. So, of course, iron, in terms of participation in physical activity, is really important for aerobic performances and also recovery from anaerobic performances. But iron is more than this. It's also crucial, I'm going to use that word again, it's crucial to myoglobin production. Now, if you're not sure about myoglobin is stored in cells, and if we think about muscle tissue, for example, within the muscle cell, a myoglobin effectively acts as a very small store of oxygen in the form of oxymyoglobin, but also it can transport oxygen within the cell to, guess where? The mitochondria, because that's the site of aerobic respiration, of course. Now then, let's take this a little bit further as well. I want to talk about I want to say what happens here for different types of people. We know that teenagers, such as yourselves, folks, and pregnant women, teenagers and pregnant women, these people require the highest amounts of iron in their diet. Okay, so for people who are growing, and including growing inside of a female, for example, in form of maternity and pregnancy, then of course more iron is needed. And again, we come back to the core process of iron for this reason. But what happens if we have a lack of iron? Okay, let's go to the negative case. Let's say someone doesn't have much iron. Let's just call it lack of. What is this going to cause? Well, this is a condition called anemia. Okay, anemia. And what happens in this low iron situation, there's numerous negative effects, but 2 that are really interesting to us is that red blood cells are smaller. So red blood cells, which are grown constantly in the bone marrow, they are grown smaller. So of course, when they squeeze through those capillaries, that's 7 micrometers in diameter, that's not going to be a sort of filling. Therefore, obviously, the rate of diffusion is going to be less. But the other factor here is the quality of our immune system diminishes. So the immune system becomes less effective. In other words, we're more likely to pick up things like illnesses, for example. Now, that's what I want to sort of share with you about iron. I'm going to take things further now, and I'm going to talk to you about calcium. Now, I'm pretty confident if I was to mention calcium to you, you say to me, James, that's really important for bones and teeth. That's what we sort of learn at primary school, isn't it? And that's absolutely true, by the way. It is important for bones and teeth, but it is at least as equally important to the process of muscle contraction. Now, I've got entire playlists on the actual specific role of calcium, the calcium ions in muscle contraction, and the sarcoplasmic reticulums and the synapses. I'm not going to get into that here. If you're interested, I do have entire playlists. We touch on it in another part of this course, but if you want to get into the real nitty-gritty of that, the material is there for you if you want. But what I want to do here is I want to ask the same question. What if we have low levels of calcium? What happens in this situation? Well, what happens here is that the bones, remember they're up here and they're containing calcium, they release calcium. So the body has its own internal structure to provide calcium, which is actually effectively stored in the bones. Now, remember, you may or may not have studied sort of bone growth and decay. Bones are in a constant state of flux. They become denser and less dense. Their matrix becomes thicker and less thick. So, of course, this would involve the bones becoming less dense through the release of calcium in this way. Now, let's think about, well, what happens if we've got high levels, which, of course, is potentially negative for sort of optimal health as well. What happens in this situation? Well, what we find here is that the kidneys release via urine, okay, so that we can actually pass excess calcium via wee, basically, okay, so that's important in that sense. Now, a couple of other things. Sometimes people will take sort of high dose supplementation of calcium. A couple of things to be aware of here. Really high dose, and of course we're talking about extreme cases here, it could lead to blood clot, and there has been an association of high dose calcium to cardiovascular disease. Now again, that's under certain circumstances, but I just want you to have an awareness of it in here. And finally, I just want to mention this last little sort of bit of nitty gritty, I suppose. I'll just sort of link it up here. And what I want you to think is there is some suggestion. So some research suggests the following. Some research suggests that calcium is capable of decreasing blood pressure. So a person that's experiencing higher blood pressure, maybe even conditions of hypertension, may be encouraged to have more calcium in their diet or even take supplements. However, this is not proven. It's not reliable. Different studies have challenged that, and that's something just to be aware of at this point. Okay, let's finish this off. I want to talk about two further minerals in this case. First of all, I'm going to talk to you about sodium. And we'll get to the sort of point much more quickly here. With sodium, I want you to be aware of three functions of sodium in the body, okay? So let's go for three functions. Here's function number one. It is really important for nerve transmission. So think about all the stuff we've done around the nervous system. Think about sort of that kind of effector mechanism, that signaling of, let's say, muscle tissue to contract. Sodium is crucial to that process. Secondly, once again, we've got contracting muscle. Contracting muscle involves the presence of sodium. Again, we're going to go into that into other lessons, but for now that will do for us. And crucially, sodium's also involved in the process of water balance in the body, but specifically not in the cells, outside of cells, okay? Outside of cells, and you'll see why that's important in a moment. And then finally, folks, I want to talk to you about potassium. Now, again, I'm not going to go into a great deal on potassium, but with potassium, I just want to mention that it's also involved in that kind of negative feedback loop of water balance, but this time potassium is involved in regulation of water inside cells. Okay, so it's intracellular rather than extracellular, which is what we're talking about with sodium. Last things from me then, I mentioned right at the start vitamins. I'm not going to touch on this a great deal at all, but just a couple of things I want you to be aware of with vitamins. I meant to do that in green. But just, let me turn my page. Just a couple of things I want you to be aware of, just as general points. Vitamins are involved in the following processes. The release of energy, which we're going to go into in lots of detail in other tutorials. They're involved in tissue synthesis, which of course is occurring at the ribosomes, as you already know. And vitamins are involved in regulation. And vitamins are really important in regulation. And let's specifically say regulation of metabolic reactions. Okay, metabolic reactions. Now that will feel fairly generic. I'm going to leave that generalism at this point as key information, and then we'll move on. Cheers.